Okay, so we are moving on in our study of quadratics, and the topic of this lesson is solving quadratics by a strategy called completing the square. And I have no idea why the font was so enormous on this, but it is. So it's big and it's bold, and we're just going to go through solving quadratics by completing the square. First thing I want to do, though, is kind of summarize the different ways that we have to solve quadratic equations and when those strategies are most useful. So there are four main strategies for solving quadratics. Remember, a quadratic equation is an equation where you do have that x squared, and the x squared is going to be the highest exponent you see. So you won't see an x cubed or an x to the fourth, unless there is a way for you to take the cubic, like the x to the third, and turn it into a quadratic, maybe by factoring out one of the x's. And we have looked at some examples that are like that. The first strategy for solving a quadratic equation is square rooting. If you think of the quadratic is x squared, and the opposite or inverse of squaring would be square rooting, then it makes sense that square rooting should be a strategy you can use. I don't actually spend a lot of time discussing or showing square rooting as a strategy because it is very limited in when you can use it. So square rooting, you can use, that's supposed to be a W. I'll try again. When your B value is equal to 0. In other words, there's no what we would call X term. Okay, so no X term. An example of that would be something like this. If you saw 2x squared minus 8 equals 0. And you'll notice this is a quadratic because it's got the x squared, but there's no x term. You go from the x squared down to the constant. And that happens when b is equal to 0. So you have ax squared plus bx plus c. If the b is 0, I'll go ahead and write it out. Ax squared, good. There we go. Doesn't want to write. Ax squared plus bx plus, I can't win. X squared plus bx plus c. If b is 0, then you would have 0x, and 0x is 0, and it ends up dropping out. That's really the only time that you can use square rooting, and most quadratics aren't like that, and you can also fall back on some other strategies. So you might be able to do like the difference of squares, or you might be able to use the quadratic formula. You can use other strategies. So, but the way this would look like if you were to solve it would be like this. We would add 8 to both sides. So we'd have 2x squared equals 8. And then divide both sides by 2, so x squared equals 4. And then you have to think to yourself, okay, what number squared gives me 4? And here's where it can be a little bit tricky, where you want to be careful, is it's actually plus or minus 2, because 2 squared would give you 4, but negative 2 times itself would also give you 4. And so this one actually has 2 answers. And that's what taking the square root looks like. So right in this step here, we were taking the square root. Okay, and that's what it looks like with the square rooting strategy. You can use it when b equals 0. I want you to be aware of it. When you do see an equation where b is equal to 0, you're of course more than welcome to use it. Factoring is the second strategy, and we've already covered that. That's a strategy that is often used. It is a must-have skill. I know students tend not to like it, but it is a must-have skill. Factoring should be used when possible. It actually is the preferred strategy for solving most quadratic equations because it is very neat and very clean. That doesn't mean it's necessarily easy all the time, but it's neat and clean. It does not involve lots of steps. In fact, it involves very few steps at all. So if you had an equation, we'll make this our example here, x squared minus 2x minus 15 equals 0. Again, you want to notice that it is a quadratic because of the x squared. This is a trinomial equal to 0. We go to factor it. and x squared factors into x times x. And then we have to go through this process of, okay, I need two numbers that multiply to negative 15, add up to negative 2. That would be what? Negative 5 and positive 3. Let me just quickly double check that before I move on. Negative 5 times positive 3 is negative 15, and negative 5 plus 3 is negative 2. We use the zero product property to set each factor equal to 0. And then here I would add 5 to both sides, and here I am subtracting 3. And you'll notice that this is about like 1, 2, 3 steps. A lot of people actually will go from this step right here with the factors to the zeros, or to the roots. And so it's like a 2 or 3 step solution, maybe a little bit more if you have to use slide and divide, if you have a more complicated factoring problem. But generally factoring is considered very neat, a very clean way of doing the problem. If you need the factors for some other part of the problem, then you would have them handy. And so typically speaking, if a problem is factorable, then you would want to factor it. Now we get to two other strategies, and today is going to be a focus on the third one, which is completing the square. Completing the square can be used anytime, but it's not good to use all the time. And so I'm going to put in here, you should use completing the square, or should consider completing the square, when your A value is equal to 1 and B is even. So that is like really messy there. So I'll go over it for those of you that are taking notes, which should be everybody. When A is equal to 1, so when you have a 1 out in front, so you just have the x squared, you would not see another number out there. And when your B value is an even number, so you have an even number right here in the middle. And we did a little bit of completing the square of several lessons back when we took a quadratic in standard form and put it into vertex form. And so you're going to be familiar with that process a little bit. It's going to look a little bit different here. Same idea. It's just going to look a little bit different than what we did when we were changing the form. Now, one of the things that I noticed on the last test was that a lot of you were trying to identify the vertex and the axis of symmetry by completing the square. You were doing this process in situations where A was not equal to 1 and B was not even, and so you were doing completing the square in very difficult situations to complete the square. Typically, this is not our go-to strategy. There are many years when I won't teach it at all in Algebra 2 because you can always fall back on factoring and the quadratic formula. So it's not one of those strategies that you absolutely have to have in your toolbox to navigate quadratic equations well. So it did surprise me that there were several people that were using this strategy in situations where even your teachers would not have chosen to use it. And then the fourth strategy is the quadratic formula. That will be the subject of the next lesson. And the quadratic formula is our like fallback, go-to, works all the time strategy. So you can use this all the time. I don't recommend that you use it all the time, especially if something is factorable or you can use the square root, because the quadratic formula tends to be very messy and very error prone. So when you need to use it, we need to have it there, but we don't usually opt to use it if we can solve the quadratic some other way. So now I'll take you through the steps for completing the square. We'll do two example problems. So I'll do this one where I'm explaining all the steps, and then I'll do another example for you. And then there'll be a practice problem in there for you to work on and kind of see if this is a strategy that you'd like to adopt. There are 7 steps to the process, but they don't actually take up tons and tons of space. And when this strategy works, it actually works really, really well. So for the first step is to move C to one side. Oops. Okay, let's try again. Move C to one side. Usually when we're solving a quadratic, we want to get a 0 on one side. That is how and why the zero product property works, and it is how the quadratic formula is set up as well. In completing the square, you actually want to get the C by itself on one side. So you're going to have ax squared plus bx equals, and then the opposite of whatever C is. So I'm sorry that that's super messy there. It says move C to one side. That's O-N-E, one side there. So in our problem over here, this is our C value. So the C value is -3, and to move it over to the other side, when we say side, we mean side of the equal sign. So I'm going to add 3 to both sides. And that is going to give me x squared minus 2x equals 3. And I did something very weird here. Like I moved the x squared, like it all got moved up a little bit. So hopefully that's not an issue for you guys. All right, so once you move it to one side, then we're going to do some scratch work off to the side a little bit here. So step 2, and this scratch will look familiar. This is going to be what we did before when we were using completing the square. So we are going to divide b by 2 and then save that number, because that's the number that is we're going to end up using in the factoring. So save that number. So this is our scratch work. Right here is our b value. B is -2. And so I'm going to divide that by 2, and I get -1. And we're going to, of course, save the -1. So I'll put like a little asterisk by it. Like we're going to save the -1, because when we get to the factoring part, that's going to be where the -1 comes back in. And that is why when you're using completing the square, you want b to be even, because an even number will divide by 2. If you have an odd number, you will end up with a decimal or a fraction at this point, which makes it not great. Step number 3 also will not seem a surprise. You're going to square the answer to part 2, or step 2. And so we're going to do -1 squared, and that's going to give us a +1. That's not super clear there. So that's equals 1. Now, in the completing the square version that we were doing before, we would add this number into like the equation somewhere, and then we'd subtract it because we had to balance it out. We have to do the same thing here, where we have to make sure that we keep the equation balanced. So the golden rule of algebra, whatever you do to one side of the equation, you have to do the other side of the equation. We're just, instead of doing like a +1 -1, we're just going to add 1 to both sides. So step, whatever we're up to, step 4 is add your answer to part 3 to both sides. So add answer to part 3 to both sides of the equal sign. So that's going to look something like this. You'll have x squared minus 2x plus 1. And then in order to keep it balanced, you have to add the 1 to the other side as well. Okay. Now, like I said, there were 7 steps. We have 3 steps left. I can count. And I'm also out of colors, so I need to go change up my palette here. Let's go with orange. All right. So step 5 is going to be to factor the left-hand side. So factor and use answer to part 2. Okay, that would be what we saved up here, the -1. So you could go through the factoring the long way, where you say, okay, I need 2 numbers that multiply to 1 and add up to -2, and that's going to be -1 times -1, and x minus 1 times x minus 1. You don't have to do it, because it's always going to come out like this. Okay, it's going to be whatever number you got up there is what's going to go into your parenthesis down here. And that's what completing the square is. So that factors into x minus 1 squared, and then 3 plus 1 is 4. Now we're going to kind of kick it back to the other strategy we had over here, which was the square rooting. Because if you look at this, I actually have what's called a perfect square. That's that completing the square. You're adding something in that makes it a perfect square. So let's use gray. We are now going to square root both sides. So square root both sides. So I'm going to square root this and I'm going to square root this, but remember that you have to have the plus and the minus for the same reason, because what you've got here is something squared gives you 4, and there's actually two things that that will work there. When you square root both sides, if you square square root something squared, you will get whatever's inside. Let me just establish that for you. So if I have 4 squared, that gives me 16. If I take the square root of 4 squared, that would be the square root of 16, or 4. Okay? So you kind of follow that. If you have x squared and then you square root it, you're going to be left with just x. Now, it's like, this used to bother me when I was in high school, is why do you sometimes put the plus minus there and sometimes you don't put the plus minus there? There's a good reason for it, and but I don't want to get into that right now. Just suffice it to say that that's going to make the square rooting go away, or the squaring go away. My apologies there. So if you square root the squaring, those undo each other, and you're going to be left with just the x minus 1. And then the last step, what color? I haven't used brown in this, so crud. Back over here. Nope. Okay, that's all we're gonna get. I can't cross that 7 because it keeps kicking me back to the other page. Now we have to solve for x. And so we'll have x minus 1 equals 2, and then we'll have x minus 1 equals negative 2. So you actually split it. Good heavens. Let me try that one more time. 2, negative 2. Okay, and this is an equal sign. And of course, we'd add 1 to both sides, so x is equal to 3. Here we're going to add 1 to both sides. I can't win. Negative 2 plus 1 is negative 1. And nope, it does not want to let me write. There we go. I'm not even going to try to circle that because I will be clicking over to, I'll be clicking forward and backward and all over the place on that. So there are the steps to that. You should write this down, not just take a picture of it, not say, oh, it's saved in Teams, I can go look at it later. You really should be writing this down, because the act of writing it down is going to help your brain remember it. So, so there you go. The steps for completing the square, and there are 2 answers. We have x equals 3 and x equals negative 1. Now you could have also done that by factoring, and it would have been a lot cleaner and a lot easier, which is why we prefer factoring over the other strategies, but it does make a good example. I'm going to do one more example to kind of work through these steps. So for the second example, what I did was copy the steps over, but I copied this abbreviated version. And that's really how you want to move through the material. The first time you see a problem, or the first time a new process or concept is introduced, we need to do it in a lot of detail. We need to make sure we understand what's happening. As you get practice with it, you should abbreviate it. You want to keep scaling back on that until you don't need it at all. You don't need to look at it at all. And that only comes with repetition and practice, which is dry, but it is how we lock things into our brain. So just to review, the reason why completing the square is a feasible way to do this is because the A value is 1, and because the middle number, or the B value, is even. If it is not those 2 things, this is not a good strategy to use. So we're going to move C to one side. When I look at it, I see that that is already done. So we already have the 5 by itself. Now I'm going to take my B value and divide that by 2. And that usually happens off to the side. And I'm kind of like annoyed that I have this one and it is the same numbers. So sorry about that, guys. Then we're going to square that number. And then the result of that is what we are going to add to both sides. So x squared minus 2x plus 1. And then we have to add the 1 to the other side to keep it balanced. Now we're going to factor the left-hand side. It could be the right-hand side, but usually it's going to be the left-hand side because you're just going to write it that way. But the way the factoring works, it's always, always, always going to factor into x, and then either plus or minus whatever the result of that first step there, or step 2. And then that's equal to 6. Now we're going to square root both sides. And usually we wouldn't show this, but square root here and square root here. And just remember this side over here, you have to think plus or minus. On the left, the square rooting undoes the squaring. Now over here, you notice that 6 is not a perfect square, so you can't really take the square root of 6. You can use your calculator, and your calculator will give you some hideous decimal for it, but in math world, we actually want to leave it as plus or minus the square root of 6. So we're just going to leave it there. And then step 7 is solve both equations. Now in this case, we would add 1 to both sides. So we do plus 1, and we end up with 1 plus or minus the square root of 6. There are two answers there. Okay, x is equal to 1 plus the square root of 6, and x is equal to 1 minus the square root of 6. If you are able to do the subtraction, like we could over here, so we could do not subtraction, but whatever the process is. Like, so one of them is subtraction, one might be adding. So this would be like 1 plus 2 and 1 minus 2. If you're able to do it, then you're going to split it up and get your two answers and write them separately. But if it's not a procedure you can do, like 1 plus the square root of 6 is just 1 plus the square root of 6, you can't do anything with that. You're welcome to leave it just as the plus or minus. And so there's your answer. So when this strategy works, this was 1, 2, 3, 4 steps with a little bit of scratch work off to the side. When it works really well. And it does work all the time. When it's ugly, it's just not worth it to do it this way. So we're going to put a practice problem up there. And the practice is this, x squared plus 8x is equal to 11. And I'm going to put the answer up there at the same time. And that's not so you can tell me what the answer is. That is so that you'll know if you've done it right. This should be x is equal to -4 plus or minus the square root of 27. We haven't really gone over simplifying square roots yet. So that would actually be the same as -4 plus or minus 3 root 3. Okay, if you simplify the square root. So that's the answer you're aiming for. And the goal is to just see right now if you can get there with the steps and following the steps that I provided. So we'll stop the video at this point and see what you can do with that. I will, on the next slide, work the process out for those of you that are making up or watching the video on your own. All right, so for those that are doing this as a review video or whatnot, here's what the solution would look like with all the steps. So we take the b value and divide it by 2. Notice that c is already by itself over there. We want to save the 4 because the 4 is what's going to end up going into the parentheses when we factor. I'm going to square the 16. Square the 4 to get 16. Now I'm going to add 16 to the left, and I'm going to add 16 to the right. When I go to factor this, I know because of the strategy I'm using that is going to factor into x, and in this case it will be plus 4. And this is where the 27 comes from. Now we will square root both sides. This is where the plus minus comes in. The square rooting of the squaring will leave us with x plus 4. Plus or minus 27, and then we will subtract 4 from both sides to get -4 plus or minus the square root of 27. To do a quick review of the simplifying of the square root, square root of 27, I can factor 27 into 9 times 3. The square root of 9 times the square root of 3, well, the square root of 9 is 3. And so you end up with 3 times root 3. And so that's where the other answer of, I don't know what I'm writing there. That is not. Plus or minus 3 root 3 comes from. We will go into this in a lot more depth in a future unit when we are simplifying the radicals. So that's what the process looks like, so that for those of you that need to check the process, and that is our lesson on completing the square.